Newton's third law. You did a pretty cool experiment yesterday where you got to see some pretty dramatic effects of Newton's third law. Newton's third law states that for every force, there is an equal and opposite reaction force. Now, a lot of times this law gets misunderstood because what people don't understand is that these forces do not act on the same object. They actually act on different objects. So let's discuss the experiment that you did. You took a pop bottle, 2-liter bottle, and put baking soda in it and some vinegar in it, and then you kind of jarred it enough once you had the stopper inside so that the vinegar and the baking soda would react. Now, one of the products, and there are several, but one of the products in this reaction is carbon dioxide gas. And so you dump it in there and it starts bubbling and it starts fizzing and it starts making all this gas in here. Eventually, hopefully, if this worked well, what you saw happen was that the stopper actually blew out. And so if this is my stopper, the stopper actually blew out and went this direction. And then because you had this bottle sitting on pencil so that it has a place to roll, the bottle ended up shooting back that direction, okay? So let's analyze this in terms of Newton's third law. So you had the gas, the carbon dioxide gas on the inside of the bottle, and the gas exerted a pressure on the stopper. The equal and opposite reaction then is that the stopper was exerting a pressure on the gas. Okay, so they're not acting on the same object. In fact, if you get the where the first force is exerted, all you got to do is switch those two nouns around. Gas exerts pressure on the stopper, stopper exerts pressure on the gas. So those are the two forces. Now, what are the results of those forces? Because remember, forces that are unbalanced will end up causing a change in motion, right? So the gas pushes the stopper in one direction. The stopper pushes the gas in the opposite direction, okay? So this should be the information that you need to finish getting your lab written up. These are the equal and opposite forces. These are the results of those equal and opposite forces, okay? So equal and opposite forces here, and these are the results of the forces there. Okay, so hopefully you can see that. You can get your lab written up. Now there are some other examples I would like to give you. If you've ever shot any kind of a gun, you know that, like, if you like to hunt, if you shoot a gun often has kick. And so you may shoot the gun, and if, like, I know my boys like to hunt deer, and so when they shoot the gun, that gun kind of kicks back and then gets them in the shoulder when they fire. Another example of this, in fact, this right here is a beautiful example of how a rocket works, because a rocket will burn a lot of fuel very, very quickly, creating a hot gas, and then the gas exerts a pressure on the rocket exerts a pressure on the gas, and so the rocket ends up going one direction and the gas will go the other direction. Okay, so that's how rockets fly as well. And even something as simple as, if I decide I'm just going to lean here on my board, I'm exerting a pressure on the wall is exerting an equal and opposite force back on me. Okay, if I'm standing on the floor, I am exerting a force on the floor is exerting an equal and opposite force back on me. Okay, it's a little more easily observable in a situation like this, but it's going to happen with any two objects that are in contact with each other. If you have one force, there's going to be an equal and opposite reaction force that occurs with it. So with your homework assignment today, you'll get some practice determining what those equal and opposite forces are.